Hello everyone, this is group 3 presenting on the topic general structure of robot manipulator. I am Sayum Punso presenting introductory and basic components. Pemanamdu will be presenting on the working principle of robot manipulator. Sonam Tupge will be presenting on the type of robot manipulator. And lastly, Pema Chring will be presenting on the application of robot manipulator. Hello everyone, I on behalf of Group 3 would like to brief you about the introduction of robotic manipulator. So, a robot manipulator is an electronically controlled mechanism consisting of multiple segments that performs tasks by interacting with its environment. They are also commonly referred to as robotic arms. So, it means that a robotic manipulator is like a robotic arm that can move parts around to do different jobs. It controls by electronics and have several segments or pieces. So this device plays a crucial role in tasking that requires precision, consistency, and the ability to handle repetition actions. For example, for an industrial application, for assembly line, for manufacturing cars, a robotic manipulator is in this environment might be used for tasks such as welding parts of the car by car body together. A robot arm can weld exactly at the right spot with the correct amount of heat, ensuring that each weld strong and clean. That shows the precision. So the robotic perform the same weld process repeatedly, ensuring to have the same quality and strength. This consistency performance helps maintain the high product standard. So the robotic manipulator can work for long hours continuously welded car parts without fracture or error, which would be difficult for human workers to sustain. That shows the handling of repetitive action. So the study of robot manipulators involves dealing with the positions and orientations of the several segments that makes up the manipulator. That means that studying this manipulator means looking at how each segments move and position itself. So next, the manipulator are composed of an assembly of links and joints. They are made up of links, that is a piece that connect, and the joints, piece where the pieces are moved, place where the pieces are moved. So the key components of robotic manipulator or robotic arm is: first we have base, second we have joint, third we have links, end effector, actuator, sensor, control system, motor, and lastly we have power supply.
So now I am going to present on working principle of robot manipulators. So we have the mechanical structure. A robot manipulator consists of a series of interconnected links and joints that form a kinematic chain. The links are the rigid members that connect the joints, and the joint allows for the movement in various directions, such as rotation or linear motion. It is designed to provide the manipulator with a specific range of motion and dexterity. Second one, we have the actuators. Actuators are the devices that provide the force and motion to the robot manipulator. They convert energy, usually electrical or hydraulic, into mechanical motion. Common types of actuators include electric motors, pneumatic cylinders, and hydraulic cylinders. The choice of actuator depends on factors such as power requirement, speed, and accuracy. And we have the control system. The control system is responsible for directing the robot manipulator's movement. It receives input from the user or highly level control system and translates it into commands for the actuators. The control system can be open loop, closed loop, or combination of both. In closed loop system, the control system uses feedback from sensors to adjust the actuators and ensure accurate movement. And we have the sensors. Sensors are used to provide feedback to the control system about the robot position, orientation, and environment. Common sensors include encoders, potentiometers, and force sensor. This feedback is essential for precise control and to ensure the robot manipulator perform its tasks safely and accurately. And we have the end effector. The end effector is the tool or device attached to the end of robot manipulator that interact with the environment or the object being manipulated. End effectors can be grippers, welding torches, or any other specific to the task hand. And last, we have the programming. Robot manipulators are often programmed to perform specific tasks for sequences of movements. This can be done using various programming languages or graphical user interface, depending on the robot's control system. Some common methods of programming robot manipulators include teach, pendants, lead-through programming, office programming, and scripting languages such as Python, which allow for more complex control and integration with others.
Next, the types of manipulator robots. Manipulator robots can be classified based on their structure, movement capabilities. Each type has its advantages and disadvantages, making them suitable for specific applications. What are the types? Types include Cartesian robots, manipulator robots, cylindrical manipulator robots, spherical manipulator robots, articulated robots, and scalar robots. So first one, Cartesian manipulator robots. Cartesian manipulator robots, also known as gantry robots, have a linear design, consists of three orthogonal axes, X, Y, and Z. These robots move in straight lines along each axis, allowing them for precise positioning and movement within a defined workspace. The structure of Cartesian robots typically includes linear actuators or slides, which enables the robot to move along each axis independently. Cartesian manipulator robots is known for their high accuracy, repeatability, and scalability. Cartesian manipulator robots are limited to only linear parts, making them not suitable for application requiring complex and curved trajectories. And these robots are commonly used in industries such as manufacturing and automation because their precise positioning capabilities makes them ideal for a tasks such as pick and place operations, assembly, and inspections. Cartesian robots are often employed in electronic industries for assembly of printed circuit boards, where high accuracy and repeatability are crucial for placing small components accurately. Cylindrical manipulator robots. Cylindrical manipulator robots have a cylindrical workspace and consists of combination of linear and rotational movement. These robots typically includes features such as vertically linear axis, that is Z-axis, a radial linear axis, R-axis, and rotational axis, theta-axis, around the vertical axis. The structure of cylindrical robots often includes a vertical column mounted on a revolute joint at the base and with an arm that can extend radically around the column. One of the main advantages of cylindrical manipulator robots is their ability to reach around the obstacle within their cylindrical workspace. This makes them suitable for applications where access to the target may be obstructed. Their vertical column and radial arm design allows them to occupy less floor space compared to other robot types. But cylindrical manipulator robots work envelope is confined to a cylindrical shape, which may not be suitable for applications requiring a larger or differently shaped workspace, and the accuracy and repeatability is lower compared to Cartesian robots. Cylindrical manipulators are commonly used in industries such as assembly and packaging. Next is spherical manipulator robots. Spherical manipulator robots have also known as polar robots and has a spherical workspace and consists of combination of linear and rotational moments, same as the cylindrical manipulator. And this spherical robot comes with an two revolution and prismatic joint. The structure of spherical robot often includes a base mounted on an arm that can extend radically and rotate around the two perpendicular axes. One of the main advantages of spherical manipulator robots is their ability to cover a large workspace with a relativity of small footprint. Spherical robots can provide a high degree of dexterity, making them suitable for applications requiring complex and precise movements. The complexity of their movements can make programming and control more challenging compared to other robots. That makes it limitation. Accuracy and repeatability is lower compared to Cartesian robots, and spherical robots are commonly used in industries such as material handling and welding. So next, articulated manipulator robots. Articulated manipulator robots, also known as robotic arms, have a complex structure consisting of multiple joints and links that allows for a wide range of motion. The structure of articulated robots often includes a base mounted on a base mounted arm with multiple segments, each connected by a joint that allows for a rotational moments. So one of the many advantages of articulated manipulator robots is their degree of flexibility and dexterity. These robots can be designed with a various number of joints and links, allowing for customization to suit specific application requirements. These robots has a complex structure that can make programming and control more challenging compared to other robots. And these robots' accuracy and repeatability is lower compared to Cartesian robots. These articulated manipulator robots are commonly used in industries such as automotive and aerospace. Next, SCARA robots. SCARA robots stands for Selective Compliance Assembly Robotic Arm or Selective Compliance Articulated Robotic Arms. 4-axis SCARA robot consists of inner link that rotates about the world z-axis connected to the outer link that rotates about a z elbow joint, which in turn is connected to the race axis that moves up and down and also rotates about z axis. And alternative configuration has the linear z motion as the second axis.
To go on with the application of robot manipulator, number one, under manufacturing industry, we will have assembly, we will have welding, painting, and material handling tasks. Number two, under health sector, we will have a surgical. Number three, agriculture sector. Under agriculture sector, we will have a harvesting, burning, and sorting. Number four, we will have a space exploration. We will have satellite development. We will have a maintenance of spacecraft. We will have collection of samples from the celestial bodies. Number five, logistics and warehousing, palletizing and inventory management. Number six, Under food and beverage industries, we will have packaging, we will have sorting and quality control tasks.